Hi, everyone. My name's Kurt Menke with Bird's Eye View GIS, and welcome to my workshop for Fed Geo Day 2020. We're going to be working with data visualization and cartography in QGIS. So I'm based in Albuquerque, New Mexico. I run my own consulting business named Bird's Eye View. And I do a little bit of everything. I do cartography, spatial analysis, modeling, web mapping, whatever clients need. And more recently, it seems like I've been asked to do quite a bit of training. I help form the QGIS certification program, and I'm a QGIS certified trainer, which means that for some workshops, I can provide a QGIS certificate to attendees for completing the workshop. We're not set up to provide those for Fed Geo Day 2020, but I provide those for most of the custom professional courses and workshops that I teach. I'm also part of an organization called the Q Cooperative, which is an umbrella organization consisting of myself and 7 or 8 people based in Europe who are a combination of core QGIS developers, developers of QGIS Server, power users of QGIS and PostGIS, GeoServer, things like that, and trainers as well. And our mission is to provide QGIS support services, largely in the United States, but we could work anywhere. But there's really a dearth of organizations and businesses providing support around QGIS in the United States. So if people need new features in QGIS, custom plugins, we can provide that. I have a couple shameless plugs here. The first is I've written several QGIS books, and one of the more recent ones is Discover QGIS 3X. A lot of what we're going to go through today is in this book. It's a broad treatment of QGIS. It's 400 pages long. It has 32 lab exercises. It goes through everything from an introduction to the GUI to spatial analysis, basic cartography, dealing with data, working with PostGIS inside QGIS, and then a section on data visualization and more advanced cartography at the end. So you can pick this up at Locate Press, and it's available as an ebook or a print. Last fall, I also came out with a book named QGIS for Hydrological Applications with my co-author, Dr. Hans van der Kwast, who's a Dutch hydrologist. And this is recipes for catchment hydrology and water management. So you can learn how to use tools within QGIS to delineate watersheds and also do a lot of other hydrology related analyses and then style the results nicely too. We made sure that the book not only covered the hydrological applications, but also taught you how to just generally work with QGIS to provide nice output of the results as well. This is another book through Locate Press, and it's available from their website. So this is going to be a QGIS tour today. We're going to try to cover quite a few things. It's kind of a modular workshop, and we're going to start out with some things that have been around in QGIS for quite a few years at this point, but are often either overlooked or people don't realize some of the interesting use cases for them. So I'm talking here about live layer effects and blending modes. We'll then work with some of the renderers in QGIS, like inverted polygon shapeburst fills. We'll look at expression-based styling and making a colorful map of the US. We'll build on that to visualize photo points with wedge buffers and raster image fills. And that will segue into a section on geometry generators. And then we'll finish up the afternoon looking at native QGIS 3D environment, the time manager plugin, and mesh data. And along the way, I'll mention how some of these things are going to be changing in the next release of QGIS 3.14 Pi. I should also mention that this is a streamlined workshop. This is, like I mentioned, it's a modular workshop where we'll be working on different topic areas and opening and closing different QGIS map projects. And normally this would be a full day workshop if we were in a face-to-face environment. This is going to be with our 3 hours plus breaks and a little bit of a late start. We'll see if we can get through all of this. But there is a fuller one that I'm able to teach if people are interested in that. Quite different. Last year I taught 17 face-to-face workshops, and I actually completed what I called the QGIS hemisphere slam where I taught at least one QGIS workshop in each hemisphere of the Earth. I was all over the place, so it's been a very different experience this year. So we'll just see how this goes. So this is a map. I work with a lot of conservation clients, and it seems like when they want me to make a map, I'm often asked to make a map that, in my opinion, might be better as 2 or 3 maps, and they want everything on one. And especially with like multiple polygon layers that cover one another. And so I'm not saying this is the most beautiful map, but this map incorporates some of the things that we're going to go through first this afternoon. So for example, it has an inverted polygon shapeburst fill that makes the study area pop off the map a little bit. It's employing blending mode so that you can see some of the base map through some of the polygons, which are grazing allotments in this case. Whoops. And then live layer effects. So there's a layer effects allow you to add outer glows and drop shadows and inner shadows and things like that to vector features. So here, this one kind of complex polygon has just a subtle drop shadow applied to it to help it separate from the map a little bit. And I'm assuming everyone is, but if you're not familiar with the layer styling panel, we're going to employ this quite a bit today. Niall Dawson had this great tweet when it first came out. He said, "I've said it once and I'll say it again. Madman Wu's QGIS style doc is the single greatest advance in cartography since Mercator's discovery of the North Arrow in 1972. So indeed, this is an addictive tool, and you can use F7 to open it up, or you click the little paintbrush icon in the upper left corner of your layers panel here to open it up, and it usually opens up on the right, or if you're in a multiple monitor situation, you can have the styling dock be free floating in its own monitor or something like that if you want. But it gives you full access to all the styling options for a layer. And the beautiful thing is that in this case, I have counties and I'm styling them by population, a chloropleth map, and I can change the mode, the color ramp, the number of classes, all of that very quickly, and see the result instantaneously on the map. So especially if you're looking for that perfect color or something like that, the styling dock is a fantastic tool. And it avoids this ArcMap issue. If anyone here has ever been an ArcMap user, this used to drive me nuts when you get 5 or 6 layers into a style, then you have to click OK, 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 and you finally get back to see what the result looks like. We don't have to worry about that anymore. We're also going to be working with different components of a layer style. So here I have the styling panel open, and you can see first off the top, it's a polygon layer. So there's a fill component, and then there's a simple fill component. So with the fill component selected here, I'll get different options than when I have the simple fill component selected. When simple fill is active, then I can change the color, the fill style, the stroke color, the stroke width, all of that. So we will be using some renderers that have multiple tiers in this hierarchy of the symbol, and you get different options for selecting different ones. And so I just wanted to make sure everyone's cognizant of that. And there's also renderers and what I call sub-renderers, symbol layer types. So I'm going to reboot this a little bit. So first off, we have quite a few renderers that most people are familiar with: single symbol, categorical, etc. But then we also have symbol layer types. So simple fill is the symbol layer type by default for polygons, but I can change that to quite a large list of other options. And so we're going to start playing with these when we get into inverted polygon shapeburst fills, which is an inverted renderer combined with a shapeburst fill as the symbol layer type. And so when you start combining this huge list of options, the options are almost unlimited. And so this is, I think, one of the kind of forgotten strengths of QGIS is that we simply have a huge number of renderers that we can use. So for example, for polygons, we're going to use inverted polygons here this afternoon early. We're also going to look at geometry generators, which would be one of the symbol layer types you can use in concert with that. Shapeburst fill, like I just mentioned. For points, there's some really nice ones like point displacement, point cluster, or even rendering points as a heat map. And so these are fantastic, quick options for rendering complex data that can really help. We're going to use the symbol layer type of raster image marker, which lets you symbolize a point based with an image photo. And on the raster side, we're going to work with the hillshade renderer here this afternoon as well. I'm also going to we're working with the color picker, which is fantastic. You know, here in the styling dock, when we go to choose a color, we have multiple tabs. The color wheel is one of my favorite ways to pick just the perfect color. There's also color swatches here that you can use to store or use default ones. And then the color picker being shown here lets you pick a color from any place on your desktop. So a PDF or a web page, for example, if you're designing something that needs to match an organization's look and feel, it's really a fantastic tool. And during the workshop, I'm going to give you specific RGB codes from time to time for specific colors to make an effect work. So for that, we have these RGB hue saturation value, red, green, blue sliders here. So I'll be giving you RGB values that you can just plug in to generate the color. Below that here, we have an opacity slider. And below that, there's actually an HTML hexadecimal color. So QGIS is able to work with colors in almost any way you can define them. And first, let's start out by just, if you haven't installed this already, we have several map projects that are going to have base maps loaded in them. So I'm going to start off by having you install the QuickMapServices plugin in case you haven't. So I'm going to have everyone just go to the plugins menu in QGIS, select that first option, manage and install plugins. And like all the GUIs in QGIS, all the windows, there's a little search box at the top here. So you would go to the All tab in the Plugins Manager, and it's a huge list of plugins these days. So you can simply start typing the word quick to filter the list of available plugins and make that easy to find. So you're going to look for QuickMapServices and install that. And this is a fantastic plugin. If you haven't used it, the base maps that stream with this will project on the fly. They will also, you can add others to it. So it's a fantastic tool, and it's for anyone who is using the old Open Layers plugin. Don't use that anymore. QuickMapServices is the one you want to use to add base maps to QGIS. I will give you one. I'm going to bring up QGIS here. So one thing, when you first get that plugin installed, it's going to show up under the web menu here in QGIS. And so you'll see Web QuickMapServices. And initially, your list is going to be quite short. And so what you want to do is go to this settings option in QuickMapServices. And you only have to do this the initial time you open it up and run it. This is a one-time thing. But in the settings, you go to the More Services tab and click this Get Contributed Pack button. And this is going to install all the, there's some proprietary base maps in here. So this brings in a much larger list that includes some of the proprietary base maps that you can add with this plugin. So when it's downloaded, you should get a message, click OK and save to dismiss that window. And now when I revisit the web menu, QuickMapServices, you'll have a pretty large list. At last count, there was over 150 different base maps in here. So this includes the Microsoft Bing base maps, all the common Esri base maps, Google base maps, OpenStreetMap, Waze, Strava, Stamen. So a lot of great stuff in here. So the first thing we're going to get our hands on this afternoon is working with layer effects. And so this is going to be found in the layer styling panel. There's a layer rendering section. And so when you expand that layer rendering section, you'll see an option to enable effects. And so you're down here, expand layer rendering, you'll see draw effects. And when you click that, this little yellow star button opens up. You click that to open up the panel of effects. And there are 4 effects there by default. And in this effect type dropdown, you can add even more. When you use that dropdown, it will replace whichever one you had selected. So the one caveat with that is the source here is the original styling of the layer. So you don't usually want to replace that with an effect. You might want to choose another one like outer glow and then replace it with another effect type in that list. I don't know why this still only allows those 4 other options to be displayed initially, and others have to be added. It's just the way it works. So with these effects, this is what some of these default ones look like. An inner glow, places a glow on the inside of a polygon. Inner shadow does the same with the shadow. Outer glow, drop shadow. And for each one of these, you can tweak the colors and the blur radius and the distance of the drop shadow extending from the feature and all of that. So you can do quite a bit with going beyond the default settings for these, which is what we'll do initially. There's also some interesting ones. There's one of the ones that's not in the list by default that you could add is blur, which blurs features. There's also a transform, which is kind of interesting. It allows you to rotate features or flip them horizontally or vertically. So I've never seen too many use cases for that, but it's interesting that it's an option. So what we're going to first start with here is some neon cartography, which again may not have a lot of practical applications, but this is a good exercise because it kind of shows you how to customize some of those effects and create an interesting appearance. So I'm going to have you in QGIS go to where you've downloaded and unzipped the workshop data, and you'll find a live layer effects folder in there. And inside that will be a project called neon.qgz. And you can open up that neon project. And it just has 3 layers. There's going to be airports, flight paths, and states, all styled with black and white colors. And what we're going to do is kind of make the airports and the flight paths have a neon appearance to them.
Yeah, could you share the link for where we get that
yes.
data folder?
Yeah, if you came in late, there, I just put it in the chat box.
Perfect, thanks.
Okay, so what we're going to do with this is we're going to first work with the airports. So I'm going to show you here. I'm going to select the SVG marker for the airports, and I'm going to give it a special color. I'm going to give it kind of a magenta color that I'm going to give you the RGB code for. So here it's 255.0.254. And I hit the back button to get back to the main styling. I'm going to give the SVG symbol a small stroke. And then I'm going to go down to layer rendering and enable effects. I'm going to give these just a default drop shadow. And the last thing I'll do is bump up the size from the default of 5 here up to 10 to make the airplanes a little bigger. So you can go ahead and work on that. Again, you're going to select the airports, open up the styling panel, which you can use F7 to open that up. change the fill color of the SVG symbol to 255, 0, 254. Change the stroke width from, I think it's set by default to hairline or something very thin, up to 0.2. Apply that default drop shadow, which again will be down in the layer rendering section that you have to expand. And then finally, change the size of that SVG symbol up to 10 from 5. So if you just kind of give me a quick indication if you've managed to finish this in the chat box, or give me a thumbs up as a reaction on your thumbnail or something like that, so I can kind of tell how we're doing here, or if we need to go over anything again. All right. Or more importantly, if I start going too fast, you can just pause me. So now that the airplanes are styled, we're going to change to the flight paths. So flight paths, we're going to do something a little different. We're going to give them the same color, and since we've already used that color initially, we will be able to find that in the recent colors for that. So when you've used a recent color, you can just pick it again, and we're going to make the stroke for the line a little thicker, 1.26. We're going to enable effects, and for the flight path, we're going to give it an outer glow. And we're not going to use the default white outer glow. What we're going to do is give it a bigger spread, and we're going to use, instead of a single color, a color ramp for the outer glow. And we're going to go down and choose a new color ramp of a gradient style, and we're going to use the color ramp designer here to choose a color ramp that goes from the magenta of the flight path to the black of the background of the states. And so it's going to basically create an effect where it fades from the flight path to the background of the states. And we're going to make that slightly, play with the opacity a little bit. You can play with the spread, the width of the outer glow effect. You can also play with the blur radius, which is how smooth the color fades across that color ramp. And so this is the detailed instructions for what I just showed. For the flight paths, you're going to change the color to the same color as the SVG airport symbol, bump up the stroke width. And then for the outer glow, you're going to expand the layer rendering section again, go in and add an outer glow, and you're going to customize that with a new color ramp that you create. Oh, I'm sorry. We are working out of, right now, the live layer effects folder, and we have a project open called Neon. So once you get done with the flight paths here, you'll definitely have a very interesting little neon cartography effect happening. You could do this with, in green or blue or some other color as well. And again, this isn't the sort of thing I practically can do with a lot of clients, but it does show you how you can tweak the settings for an outer glow, for example, and that effect of using, or the idea of blending it between the feature color and the background of the map is something that can be quite effective in lots of different scenarios. And the final step here, to kind of put it over the top, is we're going to add another symbol layer. So we're going to click the little green plus button here in our layer styling panel to add another simple line symbol. And we're going to give this a lighter pink color. So the RGB code for this is 255, 185, 255. And then the default stroke width here is 0.26. We're going to just one click up to 0.46. And that just gives it a little bit more of that kind of light effect coming off of the center of the lines. So did everyone get that to work? Great. Okay, let's, so it should look like this when you're done, something similar. So the little drop shadow on the airplanes lifts them off the flight path a little bit, and the outer glow for the flight paths creates a nice little neon effect. So you can save this project if you'd like, and we're gonna move on to another project now. This will be a little bit like short attention span theater. We're gonna go from topic to topic as we go through this afternoon. So once you've saved that, I'm going to have you open up another project in that live layer effects folder. And this one's going to be called Bathymetry. And this is a project that has some layers loaded from natural earth representing water depth. So there's about 10 layers that represent, they're polygons that represent just different depths of the ocean. There's also a shaded relief at the bottom and just a land layer. And all I'm going to have you do with this, I've already added effects to each one of these, and I've just disabled the effects for each one. But I'm going to have you select individually each one of these bathymetry layers. And for each individual one, go over to the layer styling panel, expand layer rendering, and just enable draw effects. Just check the draw effects box to enable it. The effect has already been put in place for each one of these. And you'll see a really cool kind of 3D bathymetry effect starting to take place as you enable the effects on each one of those bathymetry layers. And definitely go ahead and mute your mics unless you have something to say. You can unmute and mute yourself as you need to, but just to cut down on background noise. So has anyone figured out what effect this is? Yeah, it does kind of look like Tanaka contours. That's a slightly different effect, but very similar. So anyone see what kind of effect that is? You can put it in the chat box or unmute yourself. It's an inner glow. So if you go and you expand, click on the effects button to open up the effects panel here for one of those, you'll see that each one of those is employing an inner shadow. And I used almost the default inner shadow. I just reduced the offset of the shadow a little bit and the blur radius, and I set the color of the shadow to kind of a medium gray. So just a couple tweaks to the default inner shadow on each one of those layers, and it creates a really fantastic effect. So the last thing you can do to segue into the next topic is put a blending mode in play. So if you select the land layer so that it's the target layer in your styling panel off to the right, you'll go down to the layer rendering section, and where it says blending mode in the layer column, you can select multiply so that you add a multiply blending mode to the land layer. And what that does is allows you to see the full detail of the shaded relief underneath and still have the color of the land layer apparent as well. So blending modes are another great feature that's been in QGIS for quite a while. They're becoming more common in other softwares now, but for a long time, QGIS was definitely the only GIS that had blending modes incorporated. And these are standard algorithms that are employed in lots of Adobe products, for example, in Illustrator and Photoshop and lots of graphics programs. So there's 13 different blending modes that QGIS has. And one thing, that I often need to do is make a map that has land ownership, and it's nice to have a shaded relief as part of the map as well. And historically, if you were going to try to combine on a map like this, the land ownership polygons with a shaded relief below, you would just increase the transparency of the land ownership layer until you could start to see the relief. But there's a sweet spot. But as you start increasing that transparency of the land ownership layer, the colors become less saturated and fade out. And you also get more and more detail in the relief layer. And so there's usually, like I said, a sweet spot in there, 35% or so, that works pretty well. But instead of doing that, we can employ the multiply blending mode, and it gives you the full saturation of all the land ownership colors and all the detail in the shaded relief simultaneously. It's just a much better way to go. And on the QGIS documentation, there are explanations of each one of these blending modes. For example, the multiply blending mode, the numbers for each pixel on the top item, in this case the land ownership, are multiplied with the corresponding pixels for the bottom item, and the results are darker pictures. And so by the values, we're talking about color values. So we're going to save the bathymetry project, and we're going to open up the next project here. So we're going to go opening up a project that's in the blending folder. So navigate to our workshop data, find the blending folder, go inside that, and you're going to open up a project called Jemez. Jemez, if you've ever been to New Mexico, is a volcanic caldera. It's about an hour north of me here, and it's a beautiful spot. It's a huge, it used to be a super volcano that exploded several million years ago and left a big volcanic caldera at the top, and it has lots of elk and beautiful scenery. And so this map has some information for the Jemez. The center ring here is the actual caldera that we were just looking at in that photo. And so when we have this map open, we have a DEM land ownership layer, some PLSS townships, and rivers. And so one nice renderer that we can easily employ in QGIS is the hillshade renderer. So here, if you select the Jemez DEM, the digital elevation model, in the layer styling panel, you can choose, instead of single band gray, the hillshade renderer. So the hillshade renderer will render that DEM as a hillshade. One thing that often helps is to then change in the resampling section for that renderer, the zoomed in and zoomed out to something other than nearest neighbor. So bilinear or average usually will give you a smoother looking hillshade. So I've got mine set to bilinear and average for zoomed in, zoomed out. So here we can play with that blending mode in another setting. So first, what I would encourage you to do is turn on land ownership so that we see that, and it's opaque, so we don't see the hillshade underneath it. And if you expand layer rendering, you can play with that opacity slider. So if you start increasing the opacity of the land ownership layer, you'll see that there's a nice point where you're getting some of the good hillshade detail and still able to, distinguish the colors in the land ownership layer. And for me, that's usually around 65, 60, 70%, somewhere in there. If you keep increasing that opacity, eventually the colors become so desaturated that it's not working anymore. So once you've played with that a little bit, go ahead and just slide that opacity slider back to 100%, so it's completely opaque again. And instead of using opacity, go down to the blending mode section and give it a layer blending mode of multiply. And you'll see that you get that full saturation of the colors and all the detail in the shaded relief all at the same time. So I use this, it's probably the most commonly used blending mode, and probably one of the most common use cases for blending modes in general in QGIS. In some cases, you can also play with the brightness of the hillshade layer as well to help the effect, depending on the data you're working with. Okay, so we've now explored that multiply blending mode in a couple projects. So let's now turn on the PLSS townships, Public Land Survey System townships layer, and it's styled as just outlines of the townships, black outlines. And what I'm going to have you try is give the township outlines an overlay blending mode. So you go to give it a layer blending mode of overlay. And this mode combines the multiply and the screen blending modes. And so light parts become lighter and dark parts become darker. And it kind of works well here because we still, we may want the townships in this case to be on there for reference, but we may not want them to visually dominate the map. And so by using an overlay blending mode in this case, we can see them, but we still are having able to see the colors of the land ownership layer and the shaded relief below. And we can see all of that on the map at the same time pretty effectively. So that's one use case for overlay. Is everyone still with me getting this all to work? Okay, great. So blending modes are exposed in multiple parts of QGIS, not just for data layers. So this project has a simple print layout. So if you go to the project menu down to layouts, you'll find an option to open up a print layout called blending modes. So I've already set up a little print layout for this project, and it's basically what you have shown along with a little logo made with QGIS in there. So one thing that you can, another common use case for blending modes is using them in concert with different logos, especially if you have a logo that has some white fill in it and you want to eliminate that. Instead of creating a transparent fill version of your logo, you can simply use the white version of your logo and go into the item property section in the print layout and give this a rendering in the rendering section, a multiply blending mode, and it will strip the white away from that logo. And here we've played with multiply a bit. You could also, some other ones that are kind of interesting with this logo and this data are the soft light blending mode and the addition blending mode. So you could try either one of those and kind of see what kind of effects those create with this logo. Soft light will kind of make the logo kind of take on the color behind it a little bit, along with stripping out the white. So I use this quite a bit with my business logo. So my logo is this bird's eye view with a white background. And so I'll often just bring it in and just give it a multiply blending mode so it sits on the map nicely. And you can do this with any kind of image that you bring in. Blending modes are also available for labels, other text boxes, the outer glow or a halo around labels. So you can use it for, in quite a few places you'll see it. It's also there as part of each one of those live layer effects. So if you open up the effect and you're looking at playing with an outer glow or a drop shadow, you'll notice that there's also a blending mode that you can employ as part of that layer effect as well. So you can combine some of these to create nice effects. Okay, so that's layer blending mode, and you've seen a few different blending modes. So let's go ahead and save this Hamus project and close the print layout and save the project. And we'll move on to another QGIS project in that same blending folder. This one's called DK Roads. So DK in this case stands for Denmark. And so I taught a workshop in at the couple of the QGIS conferences that were in Denmark in recent years. And so I set this up for that. And we're looking, when we open this up, at the part of Denmark where Copenhagen is located. And we have kind of a dark background and all the OpenStreetMap roads for Denmark shown in kind of a dark blue. So I'll go ahead and open this up with you. Switch things up. Let's see. Oops, open the wrong project. Okay, so I've got this project open, and here, if I choose the Denmark OSM roads layer and go over to the styling panel, expand layer rendering, you've probably seen that there's feature blending mode here. And so this acts on individual features in a layer. So in this case, we've got, so the roads are so dense around Copenhagen that, they just merge together. The arcs are sitting on top of each other, essentially, at this scale. And so if we employ a feature blending mode, we're basically combining any of those stacked arcs and the colors associated with them together. So it's not applying the blending mode on a per layer basis, it's applying it on a feature basis. And so I'm going to give this a blending mode, a feature blending mode of addition. So go ahead and try that. When I do that, all those blue arcs where they're all stacked on top of one another, the colors are added together until they become 255, 255, 255, where there's multiple occurrences of the same arc in the same place, which is white. And so what it does is it gives us kind of a visual representation of road density. And this will scale. So as I zoom in on this, fewer arcs will be stacked on top of one another, and so the effect will change. So this is going to change depending on the colors that you're using, and then also just the symbol width that you're using would also affect how this looks. But that's a really fantastic use of feature blending mode to create a really nice visual of density. So it usually works well when there's contrasting colors. And feature blending modes also can be helped if you play a little bit with opacity of the layer as well. So these will change how, depending on the data you're using. And so sometimes you need to tweak things to get just the perfect effect you're looking for. And then we're going to finish up this section on blending modes with this one called Dodge. So this one is probably a pickier one, and one that doesn't have as many use cases, but it's kind of fun to explore what you can do with some of these different effects that you see in that list other than multiply. So go ahead and save your DK Roads project and open up the one in that same folder called Dodge. And I think when we're done with this Dodge blending mode exercise, we'll take a short break and pick up again. So if you're needing a break, one is coming. So when you open up this Dodge project, you're looking again at some of the same kind of data you were looking at in the previous one. It's roads around Copenhagen. And so we have roads and we also have these industrial areas. And let me back up a little bit. So what Dodge does is increases the brightness of features underneath whatever layer you're applying the Dodge blending mode to. So in this case, what we're going to do is move the roads to be underneath the industrial areas. And we're going to set some specific colors for both the roads and the industrial areas. And then we're going to give the industrial areas a blending mode of Dodge. And the industrial areas will essentially disappear, but they will appear, the roads that are in them will kind of appear to be highlighted. So here with the roads, I'm going to give the roads a bright red color. And I'm going to use the opacity slider to slide the opacity up and make them almost completely transparent down to like 10%, something like that. And then I'm going to move them below to the bottom of the map and move the industrial areas to be just above them. So that there's the bottom two layers in the map. And the industrial areas, I'm going to give a specific color, like a specific shade of yellow. And so this is going to be 242, 242, 0. And now that I've given that color to the industrial areas, I'm going to expand layer rendering and give this a Dodge mode. And so the industrial areas themselves disappear and the roads that are running through them become highlighted. So this is the specific instructions. You're going to style the roads as bright red lines and make them almost completely transparent, 10% opacity. Make them the bottom layer in the layers panel. And then the industrial areas you're going to move so they're just above the roads, the layer right above. And you're going to style them as a yellow color, 242, 242, 0. And if you just pick any old yellow, the effect might not be quite as strong. I picked this specific shade of yellow. This is kind of a picky blending mode. The colors have to be kind of oriented within kind of 90 degrees of one another on the color wheel for this effect to work well. You can use other colors, but the color of the roads and the industrial areas need to have that kind of 90-degree relationship on the color wheel for it to really work. And then you give it a layer blending mode of Dodge to the industrial areas. So just to show you this, if I have this finished effect, I can open up the color wheel for roads and you can see how the effect changes as you slide the color for roads around. Usually works either in 90 degrees or 180 from the other color that you're working with. Now I'm working with the industrial areas and seeing how the effect changes as I rotate that color around the color wheel in different orientations. So you can definitely use this effect with multiple colors, but you have to kind of choose the relationship of those two colors so that it works well. So let's take about a 10-minute break. So you can get a cup of coffee or a glass of water, run to the bathroom, and we'll come back at about 15 after, and we'll pick up. The next topic that we're going to work on is going to be using inverted polygon shapeburst fills to create coastal vignettes and study area masks. Okay, so go ahead and open up this Baltimore project. So this is a project, kind of a public health map. So this is a map that has Baltimore City and all the neighborhoods in it, styled by the number of diabetics in that neighborhood. And there's no HIPAA violation here because it's all fake data. It's kind of based on reality, but not real data. So just wanted to let you know that. And there are food deserts as black outlines. places where there's low quality food available, and then dialysis centers as little red stars. So one thing we're going to do here is it would be really nice if we had you know, some nice blue background for the water, and we could also do something to make the city of Baltimore pop off the map a little bit more. And so, you know, kind of an old school hacky way of doing it, we could just give the background of our map a light blue color, but we're going to do something quite a bit better than that. So we're going to use this thing that many of you may have heard of already because it's not that new anymore, but inverted polygon shapeburst fills, and it starts getting us into playing with some of the different renderers in QGIS. So the inverted polygon renderer basically inverts the geometry. So if we give an inverted renderer styling to Baltimore City, it will be styled as everything outside that polygon. And the shapeburst fill is just simply like what we did for the neon map, where it creates a shape burst from the outer edge of a polygon to the inner edge or something like that. And we're going to look at 2 use cases. So we're going to first do a coastal vignette to create the Chesapeake Bay blue water color, and then we'll give a study area mask using a similar effect. Okay, so we're gonna I'll demo this first. So I'm gonna first duplicate the county boundaries. I just right-clicked on it and chose duplicate from the context menu. And now I'm gonna give this duplicated version of the county boundaries an inverted renderer. And so you can see now it's filling in the water because it's inverted county boundaries. Then I'm gonna give it a shapeburst fill instead of a simple fill. And with the shapeburst fill, I can choose the 2 colors. So I'm going to choose a light blue and a dark blue for the 2 colors of the shapeburst fill. You can also use color ramps for shapeburst fills, but here I'm just picking 2 individual colors. And now I have a water effect without even having any data for it, which is fantastic. And so I can make this a little more refined. I can use the set distance parameter to control how far away from the coastline you get the deeper blue. And I can use the blur strength to control how smoothly the 2 colors fade into one another. So first, you want to select the Maryland County boundaries layer and duplicate it. Right click, and from the context menu, choose duplicate. The copy will be turned off by default, so make sure you turn it on. And select that layer so that it becomes the target in the styling panel. So at the top of the styling panel, it's going to read Maryland County Boundaries copy. And we're going to use an inverted renderer for that. So choose inverted polygons. And then down below that, we're going to, one step at a time. So yeah, right here, we're just doing the inverted polygon piece. So we're going to choose inverted polygons as a renderer for this duplicated layer. And then once we've done that, we're going to select the simple fill component and change the symbol layer type from simple fill to shapeburst fill, which should be right above it in the list. So now we have an inverted polygon shapeburst fill, and we're just going to adjust the parameters for it. So instead of the default colors that are there, we're going to choose the first color as 225, 255, 255. So be careful on these colors. They all, it's easy to conflate those. It's 225, 255, 255 for the light blue first color. And then 166, 206, 220 for the darker blue. You can experiment with your own shades of blue too. These are, just suggestions that worked well. So a light blue and a dark blue for the first and second colors. And then for the parameters down below, by default, it's set to whole shape. And what we're going to do is use a set distance instead and increase that so that the deeper water gets styled with the darker second color blue. And then you can use this blur strength slider to see what that does here. I kind of liked it at about 10, but experiment with that and see what you think, both with the set distance and the blur strength, so you can kind of learn how those work and how it changes the effect until you arrive at like a nice water look that you like. And this is, this has been in QGIS for quite a while, but I still think it's pretty slick that you can create this effect for water without even having any data for it. So the last step is to add a renderer to this, to add a kind of a coastline. So we're gonna, here, I'm just adding another renderer, and it's a simple fill by default. And I'm gonna change this to an outline simple line. And I'm just gonna then make that outline simple line a dark blue. And this will add a coastline to the effect. Here it's 31, 120, 180. And you can adjust the stroke width of that new symbol so it stands out a little bit more. And it gives a little more definition to the channel. So again, to do this, you're gonna use that green Add Renderer Plus button right here. And it's always gonna be by default when you have a polygon, a simple fill, and you're going to change that to outline simple line here as a symbol layer type. And there's somebody who's sounds like they're moving a lot of stuff around. So if everyone could just mute yourself if you're not actually talking, that would be helpful. You can use these buttons here to change the order of these symbol layer components. We want the simple line to be on top. But if you ever need to shift things around in that stack, you're able to with that. We're giving it a color of 31, 120, 180, and bumping up the stroke width just a bit. Okay, everyone good with this? Okay. So what we'll do next is I'm going to demo how to create a study area mask. So it's a very similar process. I'm going to duplicate the city boundary though this time, and I'll give it an inverted polygon renderer. And again, choose simple fill and change the simple fill to Shapeburst fill. And I'm going to, again, use, instead of whole shape, set distance, but first I'm going to tweak the color. So for this study area mask, I'm just going to use basically a shade of gray, like a medium gray. So whenever the RGB values are all the same number, 135 in this case, it'll be gray. So this is a gray color. And there's actually a little trick here. There's some opacity that was in this layer. So I had to make the first color completely transparent. Whenever you see that checker box indicator on a symbol like that, it indicates that there's some transparency. So I wanted to make that first color completely opaque. The second color, white. Adjust the set distance a little bit. And then I'm going to also play with opacity. So I'm going to use the opacity slider to make this inverted renderer a little transparent so that you see some of the background for context, but it definitely makes the study area pop off the map a little bit. You can control, the thickness of that effect by that set distance parameter as you're working on something like this. So again, you're going to duplicate the city boundary, give it an inverted polygon renderer, and a Shapeburst fill tied to that. And then the first color is going to be a gray, 135, 135, 135 in this example. And you're also going to want to make sure that that opacity slider, when you set that color, is fully opaque. The second color can just stay the default white. The set distance I set to about 4. You can knock that down to 2 or 3, and see how that changes the effect. And then finally, the opacity slider is I set it at about 65. And you can also play with blur strength of this too to see if that gives a smoother effect. So with just a couple simple tweaks to existing layers, we've gone from the map on the left to the map on the right, without even adding any data, just duplicating layers and adding these layer effects to them. So just keep this in mind. It can be a really easy way to make a map a little more exciting to look at. Everyone get that to work? Okay, so now we're going to move into something a little more involved. We're going to try to duplicate this kind of historic look of the old US states. So for this, you can go ahead and save this Baltimore project, and I'm going to have you open up a brand new project, an empty project, and we're going to add some data to it. And so in this exercise, first you're going to learn about this topological coloring tool that came out a couple versions ago with QGIS. So topological coloring. So if we go back to this map, you can see that there are no two states that border each other that share the same color. And so that's topological coloring, where you want to color polygons so that you use basically the minimum number of colors, but don't get any adjoining polygons that have the same color. And so what we're going to do is run this topological coloring tool to add an attribute column to our data that we can use to render our data that way. We're also going to be working with expression-based symbology via these data-defined overrides. So these data-defined overrides, I'm going to let this reboot, are really one of the hidden powers in QGIS. You see these little widgets next to lots of symbol options and options for inputs to processing tools. And with these, you can use them to point to an attribute column to populate a parameter for symbology or a processing tool, or you can use an expression with these as well. And so these kind of unlock the possibilities of using the expression engine in QGIS, which is really where you get most of your interesting effects. So in your brand new project, you're gonna be adding data from a folder in the workshop data called USA. Inside that folder, there's a USA geo package. So you just expand that. And so you can use the browser panel for this to find that USA geo package. Inside that, there's just one layer, states. And you're just gonna add states to your map. And we're using kind of a lower 48 Albers equal area projection for this states layer. So first we're going to run the topological coloring tool. So if you open up the processing toolbox, you can search for this tool. It'll be in the Cartography folder. And it's not much to set here. We're going to be running it on states. We're going to use the minimum number of colors. It will calculate that for us. So we're just going to save the output into our states geo package, but we're going to use all the defaults. So all you really have to do is point the tool to your states layer and save the output into a geo package and run that. So here you're going to find the tool, which will be in the cartography section. And save the output to a geo package, navigate into your workshop data, point it to the USA one, and I'm calling my output states colored in this case. Run the tool. And so you'll have a new layer, depending on your processing settings, may be called what you call the layer, or it may just be called colored. But importantly, if you open up the attribute table, there'll be a new column at the far right-hand side called color ID that will be populated, I believe, with 1 through 5. I think it takes 5 colors to achieve topological coloring of the lower 48. So once we're done running that tool, if you open up the attribute table, this is going to be the new data that you've created, the color ID column. So now we're simply going to use that new column to style our data with. So we're going to make the new colored states layer the target in the styling panel. We're going to use a categorized renderer, and we're going to point it to the color ID column. Hit classify, and you'll end up with your states colored with 5 different colors. I'm just removing there there's always, you know, when you use a categorized renderer, there's a category that catches any null values, but we won't have any null values, so that can just be selected and removed. We just need the 1 through 5. If you are not happy with the default random colors, one thing you can do is from the drop-down menu for your random colors color ramp, you can just choose shuffle random colors. And so you can just do that a few times until you end up with a set of colors that you think are adequate for this little exercise that aren't too garish or anything. So what we're going to do now is I'll show this and then give you the steps. So I'm duplicating this colored layer. Let that reboot. So duplicating that layer that we've colored, turning off the original and just turning on the duplicated one. So it's called colored copy here. And what I'm going to do is hit this change button. And I'm going to let this reboot again because this is important. So this change button here allows me to change an aspect of the symbology for all the classes at once. So on this new copied layer, I'm going to hit the change button and go to select simple fill and change it to Shapeburst fill. So I keep all my colors, but I convert them to a Shapeburst version of themselves. And then I can adjust the thickness. So the Shapeburst is a little thinner. I'm going to use a set distance of, I think, 4 or 5. See what I did here. So select simple fill, choose Shapeburst, and use the set distance option and reduce the set distance down to around 4. So again, here's those steps. You're going to duplicate the colored layer, turn it off and turn on the duplicated one. Click the big change button for this duplicated layer. Select the simple fill component of the symbol. Go down to symbol layer type and change it to Shapeburst fill with a set distance of 4. So that's kind of cool. You know, it creates a nice, interesting effect that you get on a lot of this historic maps with different colors, but also getting kind of that, you know, fade around the boundary of the states. Now we're going to get a little more interesting now. We're going to use a trick that Niall Dawson tweeted out a couple years ago. Today's random QGIS style tip: a marker line with a very small interval, for example, less than 0.1 millimeter, with a marker using an expression-based offset, will put random dots close to the polygon edges, gradually fading with distance from the edge. So you kind of get this stippled effect. So we're going to work on that right now. So what you're going to do is duplicate the Shapeburst version of the layer, and you're going to move the duplicated version to the very top of your layers panel. And then what we're going to do is change this back to a single symbol layer. And we're going to select Shapeburst fill and change the symbol layer type to outline marker line. And so we're going to end up with boundaries on this new version of the layer that are default red dots for the state boundaries. So this is what you're going to do. You're going to duplicate the Shapeburst filled version of the states. Turn on the newly duplicated layer and move it to the top of the layers panel. Then what you're going to do is switch it from categorical back to the default single symbol renderer. Then you're going to select the Shapeburst symbol layer type and switch that to outline marker line. Is everybody with me still? If not, tell me to pause in the chat or something like that.
Yes, we're here.
Okay, good. So here's going to be the interesting part. So what we're going to do here is I'm selecting the marker line component and I'm reducing the width interval to something very small. Let me reboot this. Whoops. Sorry. Sorry, I got to find it. Here we go. So yeah, so I'm going to, from the marker line component, reduce that width interval to something very small. So small dots, then select the simple marker section. And there's an offset for the simple marker. And what I'm going to do is use a data defined override for this offset parameter. And I'm going to enter an expression that's going to create these random dots. Then I'm just going to change the size of the simple marker to very small dots and give them kind of a dark gray fill. So to help with this, I have a Google Doc that has data visualization expressions that I use in these workshops. So you could open up this link. I can paste it into the chat for you. This will allow you to just copy and paste the expression. And I'll go into what the expression does in detail. So you'll get to know what the expression's doing. But there's a lot of expressions in this document that we won't go through today. I've highlighted the ones we will go through. First, it's called random dot boundary, and you're just going to use that concat expression that's tied to that. So again, you're going to, for your random dot boundary, you're going to select the marker line component, and you'll see an argument for width interval called width interval. And you're going to reduce that down to 0.2. And that just reduces the spacing of the marker line points. Once you've done that, you're going to select the simple marker component. And down in the offset section, you're going to click the data defined override widget, and you're going to paste this expression in. So you'll choose edit for the data defined override context menu, paste this expression in, and then you're going to just reduce the size of the simple markers down to like 0.2, very small, and make them, instead of red with a black outline, you'll make the fill and the stroke a dark gray. So they become very small, random dark gray dots. So what this expression is doing, it's basically going to, the concat function concatenates different strings of text together. So you're concatenating, and you're feeding this into the offset. So the offset argument controls how much offset there is off the polygon edge for these marker lines. So by default, they're right on the polygon edge. So here we're entering an expression for the offset, meaning we're going to be moving them off that polygon edge, but we're going to be moving them off anywhere between 0 and 3 times a random floating point number between 0 and 1 to the 3rd power. So it basically creates, a very small random number that you're using as the offset. And so randf is the function for creating a random floating point number. Oh, let's see. Can't find your processing toolbox, I see. So for the processing toolbox, you're either going to go to the processing menu toolbox, or you'll click this little gear icon. Control-Alt-T is another shortcut for it to open up the processing toolbox. If you're not seeing that at all, then it could be that your processing plugin is turned off. So you can open up the plugins manager, and processing is a default plugin that should be enabled, but sometimes becomes checked off, and you can just check that processing is turned on here. That may be one reason you wouldn't be seeing it, is that it got turned off. So that's what this expression is doing here. Okay, so we're almost there now. We have we have most of the effect done. So what we're going to do is take we have, you know, what, 3 different versions of the states at this point. We have the solid, the shapeburst fill, and the marker line. So we're going to move the solid layer, or we're going to turn it on. It's been turned off this whole time probably. So we're going to turn the solid one on. You're going to use a layer blending mode of multiply on it, and you're going to give it an opacity of 25%. So the solid colors are going to really fade to the background. They're going to be employing both opacity and a multiply blending mode for that solid layer. The shapeburst fill layer, you're also going to give that a blending mode, and you're going to set the opacity to that at 80%, nearly 100% transparent. And then what you're going to do is go to the QuickMapServices plugin that you installed at the beginning of the afternoon and turn on Google Road as the base map so that you have some context behind it. So you'll have your marker line, and then your shapeburst fill, and then your solid layer all on, and it's going to create an effect that looks something like this. And especially if you zoom in on that, it can be pretty nice to affect when you zoom into some of the smaller states. You'll see how the random marker will move as you move in. So you have your marker, your solid color. Underneath that, you have your shapeburst fill, and both of these are employing a multiply blending mode and various levels of opacity. So, you know, this probably took several years to create back when that was done, but within a few minutes, we've come up with a modern version of it that's kind of interesting. And it kind of shows you, you know, some of the ways that you can get creative using expressions for symbology inputs. So go ahead and save that. We're going to move on, and we're going to move on to a new topic, mapping field photos. And we're also going to use some interesting cartographic processing tools for this as well. So save your USA map. And if you didn't quite finish it, you can always go back and tweak it with the PowerPoint. So we're going to be opening up an existing project that's in the Photos folder, and it's called Cedar City FO. So Cedar City, I don't know if we have any BLM people here, but this is a map of the Cedar City field office, a BLM management area in Utah. And this map has several layers on it related to wilderness inventories, and ACEC is an area of critical environmental concern. It's a BLM designation. So we have ACECs and BLM lands with wilderness characteristics, which are essentially wilderness proposals. the field office boundary, and then a Google terrain base map. And so what you're going to learn in this little section is how to map photos as points by the EXIF data that exists within them, the coordinates embedded in the JPEG. You're going to see how you can represent the field of view of that photograph with wedge buffers. And then we're going to use data-defined overrides for some of the processing inputs when we create those wedge buffers. And we're also going to finish this off with an image marker so that we actually can put the photo on the map as well. I'm sorry, so this is a project that's in the Photos folder. So you're going to go open a project, find the Photos folder, and it's just going to be the one project in there called Cedar City FO. So what we're going to do first is use this tool called Import Geotagged Photos. So again, we're going to be finding the processing toolbox, and the tool we're looking for is in the vector creation folder, but you can also just, if you just import, type photos into the search box in the toolbox, you're going to find this tool pretty quickly. And this tool takes as its input a folder where your photos are located. So in this case, the photos are in a photos folder in the photos folder. So you're just going to select that inner photos folder as the place where the photos are located. You're going to save the output into the geo package that's sitting in that project. So there's a Cedar City geo package, and we're going to save the photos out to a photo points layer in that same geo package. So import geotagged photos. The photos input folder is the photos folder inside photos. I should change that, could be confusing. We're saving the output into the geo package that comes with the project. And we're not going to worry about the invalid photos. We're going to skip that and just run the tool. So then what you can do is right click on that new photos layer that got created and choose zoom to layer so that we can see them a little bit because they're only in one portion of the map, and make them kind of a bigger bright red circle so you can see where those photos are. Photo points, rather. And these photos by default are in EPSG 4326. They're in geographic latitude, longitude, and we need these to be in a Cartesian projected coordinate system. So we're going to right click on this photo points layer and choose export, save features as, and we're going to choose as the output CRS the EPSG code listed down here 26912. So that's the EPSG code for UTM zone 12 NAD 83. So when you search for the CRS, you can type that 26912 into the filter box, select NAD 83 UTM zone 12 north as the new CRS. And I saved this out into the same geo package, or you could, I guess in this example, it's actually being saved out to a shape file. This was done in an earlier version of QGIS when it wasn't possible yet to save an existing geo package layer, as a version of itself into the same geo package. That's not an issue anymore. So you could save this into the same geo package, just call it photo points UTM or something like that, or you could save it out to a shape file. Either way, won't affect what we're doing. So I called mine photo points UTM. And now what we can do is just copy and paste the symbology that you'd spent a few seconds on for the original photo points and paste that onto this new photo points UTM so that we have them as our bright red points again. And we can remove the original one. We only need the photo points UTM at this point. Give everyone a second to finish that. Okay, so now we'll get to the more interesting part. We've created our photo points from the photos, and I think there actually might be one that you received an error on that it didn't create. I tried this last night. I don't know if that's going to happen to you, but we're not going to worry about that one problematic photo if that happened. We'll work with it or whatever it created. So here what we're going to do is generate what are called wedge buffers. So wedge buffers are like regular buffers, but they're shaped like a pie slice. And so what we can do here is in the vector geometry portion of the toolbox, find the create wedge buffer tool. And we're going to point it to the photo points UTM that we just reprojected as the input layer. And so these wedge buffers are going to originate at the photo point, and they're going to extend out. And we want the wedge buffer to represent the field of view of the photo. So we want to orient the wedge buffer in the direction that the photo was actually taken in. And fortunately, the import geotag photo tool pulls that EXIF data out and has that as attributes in our layer. So what we're going to do is for this azimuth, we're going to use the data defined override, and we're going to point it to the direction field. So we're not going to use an expression this time. We're just going to point it to the direction column in our data so that when it generates these wedge buffers, they get generated in the direction that the photo is taken. So here I am hitting the data defined override, going down to field and finding the direction column and making that the input to the azimuth argument for the tool. The wedge width is just the degrees of width. We'll leave that at 45. The outer radius is how many meters, in this case, you want the wedge buffer to extend from the point. For this, I use 200. You could easily use 200, 300, 400, any number in that ballpark would be appropriate. And then just run the tool when you're done. And you get little pie slices as the output. So you're going to want to zoom in a little bit to just pick an area on the map where you see a bunch of photos once you get this produced, so that you can see the individual wedge buffers, and we can play with styling them a little bit. So this is already, even with default styling, it's kind of interesting to see it's a really nice way of showing which way a photo was taken. And so in this case, these are photos that were taken as part of a BLM roads inventory, as part of these BLM lands with wilderness characteristics. So the photos are there to document roads, and so it's nice to be able to see, in this case, which direction the photo was taken in. One nice thing now that we've worked with Shapeburst fills is that these can be a nice way to show these wedge buffers. Just select the simple fill component and change that to a Shapeburst fill. You can play with the set distance. Like here I have it set to 2.5. And you can also use then a multiply blending mode so that you see the base map and the other data layers underneath. Here I'm using just the 2-color method from black to white. And now we can make it even a little more fancy. We can actually work with our photo points UTM points now. And instead of having them symbolized as just a point, we can style them as a raster image marker. So this is something that came out for the person who's running 3.2. This isn't going to work for you. This is a renderer that came out at 3.6 or 3.8, something like that. So it's fairly new. And what it does is it allows you to pick a photograph to render as the point. So you're going to select the simple marker component for your photo points and go down and change the symbol layer type to raster image marker. So we'll be representing these photo points as a raster image marker. And it's always strange to me. This is one that doesn't seem like it's quite fully fleshed out, because this is down here, this is the point, if you can see my cursor, where it's pointing to the actual photo. we're going to use the data-defined override for this photo for the marker, and you're going to point it to your photo column in your data. So you're going to go down to field type for the data-defined override, point it to the photo field. And then your photos will appear on the map. And you can increase the size. If you make the size here, the width and the height, more like 20 to 40, somewhere in there, you'll actually see the photos pop up on the map, but they'll all be horizontal. So instead of them just being horizontal, we can take it even farther, and we can use a data-defined override for the rotation of that image marker. And you can point it to the direction field, the same field you used when you created the wedge buffers. And if you do that, then the photo will be pointing in the same direction that the photo was taken, lining up with the wedge buffer. And if you've hard-coded your width and height of the photo, that will change as you zoom in and zoom out. They become smaller and bigger. You can actually have the width and height scale as you zoom in and zoom out if you use this expression for both the width and the height. So you'd use the data-defined override for width and height. And I found this to be a nice number for this application. This is number's 5 million. I'm using the square root function of 5 million divided by the map scale. This is another expression that's in the Google Doc that I shared with you, but you can plug that into the width and height. So now you've used data-defined overrides for 3 of the parameters for this image marker. Oops. Let me go back. And so yeah, a lot of nice little features in there for rendering photos. And finally, this is kind of an interesting map. If you ever, I've had to make maps for colorblind map readers occasionally, and that can be very tricky. You may have heard of a site called Color Brewer, which has allows you to generate colorblind friendly color ramps. But QGIS also from the view menu allows you to preview things in a colorblind mode. So if you go to preview mode, you can simulate 2 different kinds of color blindness. And then it's as if you have color blindness, and you can make the map work in that way. So this is a real handy tool if you ever have to do that. So we're kind of at the end of our second hour. So let's take another 10-minute break. And for the last section, we're going to work on geometry generators, and we'll see what we can get through working with mesh data, time data, and native 3D. Okay, going to go ahead and get started. And I just want to, in this section, we're going to introduce geometry generators. And this is one of the more powerful parts of the rendering engine of QGIS. And it's, I think, kind of really giving a new paradigm of how we can work with spatial data. So what we're looking at here, and so this is the geometry generators project, and it is in the geometry folder. So these geometry generators, again, have been around for a while, but they let you transmute the geometry of a layer. And so we're going to experiment with this in this folder that's in the geometry folder called geometry generators. So what I'm going to do is duplicate this for this one layer. I'm going to duplicate, and I'm going to make the duplicated version the topmost layer and turn it on. And select it so it's the target and styling panel. And then I'm going to choose simple fill and change the symbol layer type to geometry generator. So when I do this, it gives me the geometry, $geometry, which is the geometry of each feature in this layer. And it lets me choose what geometry type I want to choose from, render this as point, line, or polygon. So I'm going to choose point for this. And I'm going to hit the expression engine button here and open up the expression window. And if you go to the geometry section, there is a huge list of geometry functions that you can use with this renderer. And I'm going to use this one here called Centroid. So I'll put my cursor at the beginning here and double click on Centroid and close the parenthesis. And click OK. And there you go. I've got centroids for each one of my polygons, just in the way the data is being rendered. And there's some other interesting things. So there's, so for this, for example, if you think about centroids, if you have an odd shaped polygon, like right here, it looks like there's 2 points in the same polygon. And that's because this odd shaped polygon, the centroid, can actually fall outside the polygon. So instead of centroid, I could change the function I'm using here. There's one called pole of inaccessibility. So I'm going to take out centroid and replace this with pole of inaccessibility. Take out the extra parenthesis. Why is that? It should. Oh, it wants a tolerance as well. I'll just give it 0. I think that will work. So whenever you choose one of these, obviously you get the syntax off to the right. So this needed an extra argument, the tolerance. And I'm just going to try 0 and see how that works. Maybe I need to use something other than 0. Okay, so here you can see now in this situation with pole of inaccessibility, it puts the point, forces it to be in the most remote part, the most central part of that polygon, even if it's an irregularly shaped polygon like this. So sometimes for this kind of effect, pole of inaccessibility might be a better option than centroid. And it takes a little longer to render than centroid, which is pretty quick. So what I'm going to do now is duplicate this first layer again. And again, make this duplicated one the middle layer. And I'm going to use a geometry generator for this one as well. This time I'm going to make interior buffers. So there is a function called buffer as well. And so I'm going to type buffer in here. You don't have to open up the expression engine if you know the name of the function you want to use. So buffer takes the geometry and then the distance units that you want to use. So here I'm going to enter a comma and I'm going to use a negative number. And so by using a negative number, it will create an interior buffer. So this is in UTM meters, so it's an interior buffer of -4,000. And I'm just going to change it from black to something that's a little more visible on this map, like maybe a light blue, for example. So now I have those same polygons rendered as interior polygons. So these are 2 very simple examples of geometry generators. You can do quite a bit more with them than that. We just have a very short workshop, so I didn't want to spend tons of time on this and not get to other things. So we went through 2 examples here or 3 examples of geometry generators. And so I want to show you, first off, when we were just working with the Cedar City Field Office project and photo points, there is actually a wedge buffer function. So instead of generating a wedge buffer layer with that wedge buffer processing tool, we could have chosen to just render the photo point layer as wedge buffers using geometry generators. So you can play around with this a little bit this weekend or tonight. We're not gonna spend a lot of time on this now, but this function is actually in the Google Doc that I gave you a link to. So I would just change the simple marker for photo points to a geometry generator, make the geometry a polygon. So we're going to render the points as polygons, and then use the wedge buffer function. And it takes basically the same arguments that the processing tool does. takes the geometry. We can still feed it the direction column to orient them, and then give it the radius and the distance. And the beautiful thing about this is that if you render them this way, let's say you thought 200 meters would work for the length of the wedge buffer, but you produce them and realize, no, I really would rather they were 400. Well, if you're just rendering the points as wedge buffers, you can go in here and just tweak any of the parameters for that and see the result immediately in the way it's being rendered. So it's a very efficient way to go when you're doing that. And there are, you know, dozens of spatial functions in there, so you can go nuts with geometry generator. So I want to give you some resources too. So for example, I know Brett Carlock earlier was saying that the interior shadows on the bathymetry looked like Tanaka contours. Well, this is what a real Tanaka contour looks like. This is Mount Rainier, and these are basically illuminated contours that a Japanese cartographer, Tanaka, came up with in the 50s. So it's possible to replicate Tanaka contours via geometry generators. I believe I have the expression for that in the Word document that you have. It's quite a bit more involved. You can also look up some good documentation on how to do this. Anita Grauser has done quite a bit on her blog about these. And to give you a kind of food for thought on what's possible, this is a gentleman I follow on Twitter, Scott Reinhardt, and so he works for the New York Times doing data viz. And he generated this map where New Yorkers moved to escape coronavirus with geometry generators. So he must have had to and from points, and he used one of the functions in there to generate curved lines connecting the to and from based on magnitude and something else, obviously. So you can do great visualizations like that with this renderer. And if you want some more resources, this URL that you have in your PowerPoint, this guy Michael Stuitz is a German guy who has a whole series of geometry generator styles that you can download and use on his GitHub page. So you can see these are all different ways he's come up with to creatively generate things with geometry generators. So you can spend quite a bit of time grokking on these. This is points as tables. So this is dynamic distance lines, really cool stuff. Also, this gentleman, Johann Kroger, he has a blog, Hans Enjoys It, and he has geometry generators for doing some other cool things that probably aren't things you do in the office, but are fun. So Joy Division maps with geometry generators, Lego maps, digital rain. So you can find all the expressions for how to do that on his page. And lastly, this other guy, these three guys are probably like three of the most creative geometry generator geeks on planet Earth. So this gentleman, I think he's Finnish, and he has a GitHub page with several interesting, and actually he's the one that did Digital Rain, not the, so actually Digital Rain isn't his. I should take that off. That was a mistake. But he just came up with this crazy one called Gustav. It's based on Gustav Klimt's art. So Q-Limt is the name of that one. There's a pencilish one, which is very similar to what we just did with the random dot marker for the US states, and this digital rain. So if you're curious about those are some really good resources you can go to explore this renderer in a little more detail and what's possible. So right now we're going to switch gears, and I think we're going to start with what I was going to finish with, because I just want to make sure we get to this because it's very cool, kind of unique, and I imagine a lot of people have not played with this yet. So this is going to be a section on mesh data. So whenever you're done, you can save the Colorado Hunt Units geometry generator map document when we'll be starting with a new map document for this section. So mesh data is kind of a new hybrid data model, and it's, if you ever worked with TINs in the Esri environment, it's very similar to that, where it has components of vector and components of raster, and it's used a lot with hydrological and meteorological data sets. And there's different formats for how the mesh itself can be structured. The one that we're going to be working with, I believe, is a regular mesh, the data set we're going to be playing with. So we're going to have you add this mesh data now. So this is working with the data source manager in QGIS. And if I reboot this, you've probably noticed that there's now a mesh tab here. And so we're going to use the browse button to browse to this mesh folder and choose Atlantic September 2017.nc. That's the data set we're going to be working with here. And this is kind of a big data set. It may take a few moments for this to load, depending on what kind of computer you're working with. You should also be able to add this via the browser panel. So it's Atlantic September 2017.nc. There's several file formats of mesh data that QGIS supports at this point. So this data set, while you're getting it loaded, covers the North Atlantic Basin for the entire month of September 2017. So it has 30 days of data within it. This was a really historic hurricane season. So there were 6 major hurricanes that went through, including Harvey, Irma, Jose, and Maria. And I got this data set from the Copernicus.eu. And so that's a really good source for this kind of data. So once this data set is loaded, it's going to look something like this by default. And you may have a little question mark next to the spatial reference. It's in EPSG 4326 if you want to define that. Shouldn't really matter for what we're going to do, but just so you know that that's what the CRS is, and for some reason it's not reading it anymore. So has everyone gotten this to load successfully? The person with 3.2 don't think this is going to work for you, so you might just have to watch. You need at least 3.6 to have this work. That's when the mesh functionality was introduced, I believe. So with this on the styling panel, you'll notice that you have kind of a different set of tabs for mesh data. So this data is fantastic because not only is there a time component, but it has wind, temperature, and precipitation all as pieces of it. So we're going to work with the wind, but there's also, let this go through. So yeah, so there's 3 components, and right now with this active over here, it's showing that what they call the contour, which is the raster component, is activated for wind. Down here, you have all these time sliders and a drop down. This tab here is for the contour data, the raster component. The one next to it is for the vectors. And then you can actually look at the structure of the mesh with that tab off to the right. So to style the contours, i.e. the raster component, you will switch to this contour tab. And what I'm going to do is choose a color ramp that's the red, yellow, blue. So I'm going to choose for the color ramp red, yellow, blue, and then I'm going to right click on it and invert it. So we're inverting the red, yellow, blue color ramp. And I'm going to reduce the maximum from 34 point whatever it is down to 25, just to kind of focus the stretch of the data on the hurricanes that we want to see a little bit more. And you shouldn't have to click load anymore. It should style the contours automatically without having to press load. So here I am switching to the contour tab, choosing the color ramp I want to use. I'm inverting the color ramp and reducing the max down to 25. So then what we want to do is work with the contours. And so what we're going to do on the very first tab right here is click the little arrow off to the right of where, you have the wind component and you have the contour activated. You need to activate the vectors, which is the little arrow off to the right of the wind line on the very first hammer and screwdriver tab here. And once you have those vectors activated, they're going to overwhelm the map initially. We will fix that. Then you're going to switch to this vector tab. Show vectors should be checked. And what we're going to do is, first off, work with the X and Y spacing. So we want to activate this and up the spacing up to 15 pixels to spread the vectors apart a little bit. So then we're also going to, for the arrow length, choose the option to scale that to magnitude. And what that will do is allow us to shorten the wind arrows based on the wind speed, and we'll reduce the scale factor from 10 to 1. So scale to magnitude by 1. And then finally, for the color, I'm going to just choose use the color picker to pick a dark blue off the map. So again, I'm going to go over here and check the arrow on that first hammer and screwdriver tab for wind, switch to the vector tab. I'm going to check display vectors on user grid and adjust the XY spacing to 15 pixels. For the arrow length, I'm going to scale to magnitude and reduce the scale factor down to 1. So it's 1 to 1. And then for the color, I'm going to choose the color drop down, choose pick color, and I'm just going to hover over part of the map that has a dark blue to choose the color. So that makes a nicer looking map initially. But we're still looking at the very first swatch of time. Oh, I want to show you too that if you have version 3.12 loaded, for the vectors, you're going to see another option now here for symbology that's brand new. You can now style these not only as arrows, but as streamlines and traces. So that can be kind of cool too. That's a very new thing that you can play with. So just to give a little context, in that same folder with the mesh data, there's a countries layer from Natural Earth. So you can add this NE10M admin 0 countries shapefile to the map and either give it a hollow fill with just outlines or a white fill and then a multiply blending mode to take that away. So here I am adding that shapefile for the country boundaries just to give us a little context to what we're seeing. And in this example, I'm going to change the fill to white and then just use a multiply blending mode. So that I have the country boundaries. And then, if you zoom into the kind of the Mediterranean, the coast off of Florida where those hurricanes really formed, that's going to be the most interesting part of the data set. And what you can do then is play with the time slider. So down here, we have these controls for jumping forward and backward in time, step by step. And this data set, again, has 30 days of data. And for every day, the data was sampled 4 times: midnight, 6 a.m., noon, and 6 p.m. So we have 4 timestamps over 30 days. So we have 120 points in time that we can look at in this data set. So if we use this time dropdown and go to day 5 at noon, that's when Hurricane Irma became a Category 5 hurricane. And you can see that. Anytime between that one stayed Category 5 for a long time, all the way up to day 8 at 0600 hours. So anywhere in there, you're going to see Hurricane Irma as a Category 5 storm. And you'll really be able to see the eye of the storm in the contour data. Another interesting point in time is day 18, September 18th at 1800 hours. That's when Hurricane Maria was at peak intensity as a Category 5 storm. So here I'm just going to zoom into the Hurricane Alley, as it were, where those went through, and then use the drop down to explore some of those times. So another thing you can do with this is you could go to the QuickMapServices plugin and add a base map. Here I'm adding Google Satellite. And with the base map added, what I'm going to do is deactivate the contours and just show the vectors. And so this is another option with this kind of data, is showing it against a base map like that, a satellite image or something, and making the contours white or something that's going to show like that. So you can use different components of this mesh data to show different things. Okay, so now what we're going to do is if I'd known that we're going to be people in here using 312, I might have changed this up because, well, actually, I shouldn't say that. It's going to be the next version. So one thing I'll mention is the temporal controller that's coming. But for now, what I'm going to have you do is install the Crayfish plugin. So all this functionality with mesh data was created by this company out of the UK called Lutra Consulting, and they have also created this plugin called Crayfish that lets you plot and animate mesh data. So you can search for this plugin and install it, and then I'll show you what you can do with it. So the main thing this plugin is going to give you is a context menu. When you right click on the mesh data, you're going to see this option to plot. We'll get to export animation next. But if we right click on the mesh data layer and choose plot, we'll get this plot panel across the bottom of our map canvas. And what we can do then is just on the from map, even though it says point, click the drop down and choose point, and then start hovering over the map. And what you're going to be doing is seeing across all 30 days of this data set, you'll see the wind speed for that location on the map across those 30 days. So if you choose Puerto Rico, for example, you're going to be able to see when the first couple hurricanes hit, followed by Maria afterwards. You can really see the spike in wind speed when those different hurricane events came over the same piece of land, just 10 days, 2 weeks apart from one another. The other thing you can do with this is create an animation, which is very cool. And this kind of depends on what platform you're running. So I can't promise any of this is going to work for you necessarily. You might have to spend some additional time after the workshop on this. But you can right click and choose create animation. And it's going to open up this animation window for you, which is going to let you choose multiple aspects of this data set to animate. So on the general tab, you can choose the date range that you want to create an animation for example. And you can also, on the layout tab, give a title that will appear on the animation. And then also on the, let's see, I think on the general tab, it's also going to give you the output file. So it's going to save this as an AVI. So here I'm choosing the start and end time, and also the dimensions in pixels that I want this to be, the frame rate, the output file, the name of the AVI. When you go to, when you enter all the parameters that you want and then click OK, it's going to give you this FFmpeg missing, most likely, unless you already have that configured on your system. So FFmpeg is an open source project that is used to create animations, videos, and it's pretty nice. If you're on Windows, you can choose to just have it download and configure FFmpeg automatically, and I've had really good luck with that. And then just click OK, and it'll export the animation and use it. So it handles all the paths it needs to find FFmpeg on your system and downloads it automatically. So the directions change depending on whether you're on Windows, Linux, or Mac. But it's going to be needing to have FFmpeg installed concurrently to work. So this is something, with such a short workshop, we don't have much time to mess with it, and especially not knowing what kind of systems you all have. You'll have to work this out individually. But what it allows you to do then is create something like this, where you get to see these storms rolling through the Caribbean. And it's fantastic. We could spend an hour or two just on mesh data alone, frankly. So one thing that I want to alert you to, and some of you may have seen this, is that we'll try to look at Time Manager next, but there's a temporal controller coming with QGIS in QGIS Pi, which is going to be 3.14, coming out in a few weeks. And the temporal controller is going to be fantastic because it's going to support vector data, raster data, mesh data, WMS time data. And it also, when you get into data-defined overrides and expression-based rendering, it includes temporal variables and functions that you can use. So QGIS is going to have all this out of the box. And it's also going to allow you to implement a temporal range for something in the print layout and choose what part of a data set you want to include time-wise in a print layout. And it's also going to expose, we didn't get to look at atlases today, but it's going to be exposed for atlases as well. So going forward in the next version, you won't need Crayfish to animate mesh data. It will be out of the box. There still might be some aspects of Crayfish that aren't exposed in native QGIS yet, like being able to name the animation and things like that. But for the most part, you'll be able to do this out of the box after 3.14 is released. Okay. So we have about 20 minutes left. And I think one good thing to finish with might be, since we're talking about it now, is looking at Time Manager. So you probably want to play around with this data set more because it's really fun. So why don't you just save your project, and we can you can get back into that later. And what we're going to do, I'm going to back up here and get back to the section dealing with Time Manager. So what I'm going to have you do is open up in the Cyclones folder, cyclones.qgz. And this data set is going to contain cyclones, the origin points for tropical storms and cyclones from 1950 to 2018. So it's over 3,000 points, marking the point where every storm started. And then what I'm going to have you do is open up the plugin manager and install the Time Manager plugin. So once you get Time Manager installed, if it doesn't open up automatically, you can go to the plugins menu and you'll see an entry for Time Manager, and you can just select that and choose toggle visibility. And what it's going to do is open up a panel across the bottom, kind of in the same place crayfish was. So in fact, you probably want to close the crayfish panel because you don't need two big panels across the bottom right now. We're done with crayfish for the time being, so we just want Time Manager up there. So we have our map with all of our cyclone points, and we have Time Manager open. And so what we're going to do is click the Settings button. And when setting the Time Manager settings open, all you have to do is choose Add Layer, and you're going to add cyclones as the layer that's going to be time enabled. And the only thing you have to do beyond that is choose the field that has the start time. And the start time here is going to be a field called Date Text, the very bottom field, Date Text. So that's a column. Right now, Time Manager works best if your temporal data is in a text column. And so this is year, month, day stored as text. That's what's in the date text column. So it's the date that the storm started. So that's all you have to do is choose the cyclones layer and choose the date text as the start time. And then click OK. So down here, it says show frame for 500 milliseconds. So that's how long each year in our case is going to last, half a second. You can change that if you need to, but we'll leave it as the default. And then for time display options, one thing that Time Manager does nicely is allows you to see the current time as you're playing your temporal data. So here we have 78 years of data, and we're going to animate it on an annual basis. So we only need the time. So if we click time display options for this date time section, we want to clear everything out except the %Y for the year. If you have other data that has a finer temporal component, you can choose to display all that. So then just close OK. And other things you can change in this window is the font and the placement of that timestamp. So I've made mine here Arial font 25 and took the other defaults. And that's really it. We're almost done with this at this point. So all you really have to do next is click OK and back out of those settings windows. And back at the main panel, choose your time frame size and set it to 1 year. And then all you have to do is there's a little power button, kind of like an old stereo amplifier. You click the little power button here so it turns green, and then press play. And you should get the cyclones animating across your screen year by year. So it's actually an amazingly easy plugin to implement and use if you have data with a temporal component in it. There is a section down here to export video. What that would do is export the individual frames and then you would use something like GIMP or some other software to string those together into a animated video. Or you can just use a screen recording software. Yep, Shotcut does that too, right? It's another good open source piece of software for doing that, taking a bunch of images and stitching them together. So going to show you what's coming with the temporal controller. The other day, I did use this same data. Niall Dawson had a great YouTube video that he about a month ago that he where he showed lots of temporal controller settings, and so this is that same data put together with the temporal controller, and this is basically this status bar down here is a basically a point that I created, and it's using an expression to control the length of the bar. And there, with the new temporal controller, so if you install QGIS 213, you can start to play with this, or 313 rather. There are temporal variables that you can use to control the, that are aware of the current time in the animation. And the temporal controller itself looks a lot like Time Manager. It's based on it. And so you can do some pretty slick things with some of the temporal variables, like set up this point to be rendered as a long line that gets longer as the animation plays. And you can also have another point that's labeled with the current time, like this is being done. So this is all going to be stuff that's out of the box with the next version of QGIS. Let's see, and the last thing I was going to show you, we can do it together real quick. I'm going to open up the last project we haven't played with in here. We actually did amazingly well getting through all this. In the 2.5D 3D folder, there's a Mount Rainier project. So this just has a DEM and a hillshade for Mount Rainier. And so right off the bat, I'm just going to give a multiply blending mode to the hillshade so that I get a nice color hillshade. That's another classic use of the multiply blending mode, is creating color hillshade effects. And then to work with 3D, it's quite simple. I'm just going to go to the View menu and choose New 3D View. And the 3D view is going to be a panel. So I'm going to make it a little bigger here. Since it's a panel, you have to be careful that it's going to want to dock places if you move it close to an edge. So there's my view in the 3D viewer. I just have to click the little configure wrench button to tell QGIS what my 3D view is going to be based on. So I'm going to tell it that it's going to be of type DEM, and that my elevation layer is the Mount Rainier DEM. And let's see, there's some things in here like the skirt height. When QGIS starts tiling this 3D view, sometimes you'll see little seam lines in the tiles, and you can eliminate some of that if you increase the skirt height value. So I'm going to bump that up to like 100 to make my 3D scene a little smoother. And I'll click OK. And so now it's basically a 3D view, but I'm looking straight down at it. So we have this nice temporal controller panel here. So this button on the lower left, tilt down, I can use to start tilting this into a 3D aspect. And then I can start turning it with the little compass arrow. You can zoom in. You can use the pan button as well. So the navigation has improved recently in recent releases with this little controller. It makes it really easy. And the other thing I was going to show you here is that if you want to create an animation, you can click the little animations play button here, and it opens up this panel across the bottom that lets you set keyframes. So I can, it's going to already have a couple default keyframes, 0 and 5 seconds. So I think I'm going to select the 5-second one and remove it. And here I'm going to add a new one where I'm just zoomed to. So I'm going to click the add keyframe, and I'll make this like the 3-second mark. And then I can rotate this around, add another keyframe, make this 2nd 6. So I've added a couple keyframes, and then I can start playing my animation. I guess I didn't do a very good job of adding keyframes there, but you get the idea. You just simply add keyframes and where you want them and start playing the animation. You can add and remove, you can edit existing ones. And then finally, you can export out the frames in the same way you could do with Time Manager and use something like Shotcut or GIMP to stitch those together. The other thing I wanted to mention about this is that you can, if you're working in the print composer, you can now add both mesh data and 3D views into a print layout. So you can, I could add this I could add this 3D view into my print layout by going to Project, create a new print layout. You'll see add 3D map here. And it's going to tell me that the scene is not set, and I can just tell it to copy settings from an existing 3D view. And there's my 3D view in the print composer. And you have all the same controls here that you do in the 3D viewer for controlling where the camera is and things like that. So it's fantastic. We went through some of it kind of fast at the end, but we did manage to get through everything I had prepared. So you guys did amazing. And yeah, and just as a shameless plug, almost everything we covered in here is covered in kind of deeper detail, along with other things in my in Discover QGIS. So especially if my hope is that book especially will be used by instructors at universities to start incorporating FOSS4G and QGIS more in curriculums. So if you know of any professors who are trying to move towards QGIS, especially with our COVID crisis right now, I'd really appreciate it if you let them know about that book, because it is kind of designed for the classroom as well. And I hope that people can use that to start having ready to go curriculum that they can use to use QGIS in the classroom. Oh yeah, when is 3.14 released? Let's see, we should be able to just open up the web browser and go to the QGIS page, because they always have that little ticker. Move this out of the way. So yeah, in the upper right-hand corner, time until next release, 6 days, 16 hours, 3 minutes until packaging. So very close. Yeah, and the roadmap that Brett Carlock just posted is really useful. Well, thanks so much, everyone. I really appreciate it. And hopefully we can do another one of these in the future. I'd like to take a moment to thank the sponsors of FedGeo Day 2020, We had a lot of businesses that made this possible. So thanks especially to OSGeo-US and Maxar. That's the end of the workshop. I really appreciate everyone. We got through everything and everyone did really well. This is my contact information. If you're interested in tracking me down afterwards, feel free to reach out and ask questions. And I hope everyone enjoyed the workshop. Thanks so much.